This video will focus on the learning target of concentration. I can calculate concentrations of a solution, including molarity, molality, and then parts per million and parts per billion, which is what ppm and ppb stand for. When it comes to solutions, we talk about concentration because in the end, when you make a solution, it's all about the solute going into solvent, but you can change the amount of solute going into solvent and it would still be a solution. So for example, if we were talking about like a salt solution, we were putting, sodium chloride into water, the process of dissociation and hydration happens. We can talk about the saturation point, but in the end, what we want to be able to talk about is how much solute there is in that solution. So concentration in general is how much of the substance we are mixing into the other substance. And the only difficulty when it comes to talking about concentrations is there are many different ways to talk about it. And the reason we choose one way opposed to a different way is really situational. Depending on what kind of solution we're talking about and why we're caring about the solute in the first place, we would use different concentration units. The other thing to realize when we talk about different concentration units is essentially we have three different things we could measure. We could measure amount of solute, amount of solvent, or amount of total solution, and depending on the different label, we use two different of these three variables. So I will highlight that as we go through. This video in terms of concentration labels will focus on four different really common ones, or at least ones that we will encounter. So molality is the first one, and we'll talk about that one. ppm and ppb, that's the second one on there, and that's how much there is per million or per trillion of something, or sorry, per million or per billion of something. Percent by volume is one we'll talk about. Percent by mass is one we'll talk about. And then, of course, molarity will be the main one we use and we have used already. So the first way we can potentially talk about concentration is concentration by volume or concentration by mass. And if you look at both of these equations, essentially it's a ratio of amount of solute per amount of solution. And the difference is that volume will be volume of solute per solution, and mass will be mass of solute per solution. So the big thing distinguishing between the volume percent or the mass percent is just to know whether you have mass or volume, right? And this is a really common one. We've talked a little bit about it before. Like if you look at isopropyl alcohol or a lot of those like liquid solutes, you'll see that they say they're like 95%. They're 95% isopropyl, or they're 3% hydrogen peroxide. And oftentimes you're going to have to look at the label to actually see, am I giving you a percent by volume, so the volume of solute per solution, or am I giving you that percent by mass, the mass of solute per solution? And it does vary. It really depends. And sometimes that information is super hard to find. But a lot of times, again, we're using these, especially the volume of solute per solution, when it's a liquid solute, just because that's a pretty easy thing to measure, would be their volume. And then mass of solute per solution is another potential option. Again, probably more solid solutes in that case, but it can vary. Okay? So you got to be careful when I'm given percents. It's a pretty noticeable distinction in terms of a type of concentration. When I give you percent, this is 25%, this is 50%, but you got to see whether it says it's percent by volume or percent by mass, because those variables then that you would use to calculate are different. A next really common label for concentration is parts per million or parts per billion, ppm and ppb. And these are really common ways of talking about concentration when we're dealing with toxic substances. So if you look up any information about like lead in water or carbon monoxide in a house, most of the time you're going to get information about that as how many parts per million or parts per billion would be allowed. So it's used for a very, 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 very small amount of solute that we would allow in a solution, because what ppm and ppb stands for is right here. It's the number of like atoms or molecules we have per million, or the amount we have per billion within our sample. And of course we understand we have a lot of atoms per any given sample, but when we're talking about like 1 part per million, that means 1 atom for every million would be your substance. So this is a very small concentration of solute in total solution, essentially. So again, we use it for a lot of like environmental things or safety things or things where what we're measuring we don't want a lot of, right? You don't want a lot of lead. Certain amounts allowed, not a lot. We don't want carbon monoxide. Certain amounts allowed, not a lot. So the standard in your house is that you can have 20 parts per million of carbon monoxide, which means 20 molecules of carbon monoxide per every 1 million total molecules in the air. And any more than that would then become dangerous. So this is for like mercury in water, right? So a lot of times when we're looking at like toxic things and environment stuff and emissions, how much carbon dioxide can a factory emit as pollution, a lot of times those are in parts per million or parts per billion. And that's essentially a count. So not by mass, not by volume. It's literally like how many stuff is being made. Molality is a new label for you guys, and I'm sorry that it's molality, where molarity is so close to the same word. Molality is a small m when we talk about it, and this one is a ratio of moles of solute per kilograms of solvent. And the big thing about molality is that as a measurement, because it's moles per kilogram, not moles per volume, is that the temperature does not change or affect this ratio. Okay, if I change temperature and I'm measuring molarity, my measurements can be affected. And the reason that's important is we're going to come back around and use molality when we talk about something called colligative properties. And colligative properties are specifically a property that relates to solutions when the temperature is changing. So molarity as a concentration is how many moles of solute I have per total kilograms of solvent. And this is the only label we will see where the denominator is solvent instead of total solution. So actually, I think of molality a lot of times when we come back to colligative properties, we're actually talking about the effects of having a solution on the solvent, where pretty much all of the other labels we look at here are about the solute. How much solute is there per billion? What percent of solute is there in total solution? So molality is very unique in that it's a concentration label where we focus on the solvent, the effects that the solute's existence has on the solvent's properties. Molarity then is the label you already know, moles per liter, but just to wrap it into solutions, please note, because we haven't really talked about it, that it's moles of solute per liters of total solution. So when it comes to measuring things, it's moles of solute, right, grams per mole, no problem, but it's liters of total solution. So we are not getting information here about the solvent. It's a question of total volume of solution. So the biggest thing is here is when you make a solution, the volumes aren't additive. It's not like if I knew my volume of solute and my volume of solvent, if I added them together, that would not be my volume of solution because of the dissolving process, okay? So just like we've done before with molarity, this will be used in that we are going to have to go grams to mole again using that molar mass. And then a lot of times we're going to be measuring mils in lab, so we're going to have to convert back to liters. Those are all the different labels. Make sure you get written down all of their relationships because mathematically, I kind of expect you to be able to do this since it's just a ratio thing. Divide one by the other. That's it. So on this quiz, you will be expected to do some manipulation of the labels. That's it. Have a nice night.